Hey, what's happening? I want to tell you guys a little story. It was the dark of the moon on the 6th of June. I was in a Kenworth hauling some fucking logs, right? Okay, well that's actually not what happened. What happened was, it was a cold ass January night. The blower in my 98 Chevy 2500 just stopped working. So key on, the switch doesn't do anything. So I looked this truck over and I found that the connector for the blower switch was melted bad. And rather than just splurging on a repair, I kind of got it working by means of a toggle. Well, I don't know if you can hear it, but it's definitely putting out some air. But I only have one speed. Now I'm going to go back in here and actually fix this, but I kind of think it's going to be cool to show you what I did to get this to work. You know what I mean? As you're going to find out, the actual fix that I'm going to do to this is going to be kind of pricey. But I'll show you the workaround, and you can make the choice if that's something that you want to do. So as you can see on this one, the connector here for the blower switch isn't even plugged in. As you've seen, when I took this out, these are connected to the toggle switch that was like right about here. So this is what I had here, a melted connector. This is kind of expensive to replace. Relay. Now before we do anything, neither of these schematics show what happens when the blower switch is turned to high. It would make this shit way too confusing. High is indicated on this part of the schematic, but it's not shown. So this red pencil is going to denote power. So when you turn the key on, power is going to come through this fuse 12 in the inner panel fuse block, comes down the brown wire, and it goes up to the switch. Now depending on what speed you set the switch to, power will then go to the appropriate circuit. We've only got one shot at this, otherwise all the lines are going to turn red. So let's just say we're going to go to the speed right before high. We're going to go to speed 3. Even though the manual refers to it as M2, we're going to call it 3. So we turn the key on, we have power that comes up to the switch. We move the switch over to 3. Now power is going to come across the light blue wire and into the blower resistor. It's only going to go through one part of the resistor. It's then going to come out. It's going to go through the closed contacts of the blower high relay. And it's going to put power to the motor. Once you get power to the motor has a good ground, that motor is going to spin. Now it's not going to spin on high because it went through part of the resistor. That's the whole power circuit. From the fuse to the switch all the way to the motor. That's how it works. Now what happened in the case of this pickup, the connection here at the switch melted. It melted the connector and it actually melted the internals of the switch. So while I had power on the brown wire going into the switch, I had nothing coming out of either of the outputs of the switch because of the meltiness inside. Now let's look at how the circuit was modified. I'm going to try to do this left-handed, so if I miss, blame Coach. Now, when you turn the key on, power goes through fuse 12 in the instrument panel fuse block. It does come down the brown wire, but the brown wire was cut at the connector. Brown wire then fed into 85 as well as 30 of our aftermarket relay. You know, in this temporary fix, I was able to pick one speed. What speed did I want to work? And I decided to pick medium 2, or what we would call 3. So in this case, my 87 from the relay went to the light blue wire. Now the rest of the power circuit remains the same. For clarity purposes, I didn't show the other 2 speeds, well technically the other 3 speeds. Technically, The two speeds that I showed up here but didn't show up here, I didn't show any of them down here. Whatever. But the rest of it goes like it should. When the relay's turned on, power goes to the resistor through the one little single resistor part of the resistor, and then power to the motor. Toggle switch comes into play because it turns on the relay. The way it works is pretty simple. One wire goes to a ground point. I just chose a spot under the dash, and that ties into 86 on our relay. So the way this works, when the key is on, power comes in to the relay, and it also supplies power to the feed side. When I turn the switch on, ground goes through that little switch, trips the relay, and that puts our power from fuse 12 right onto the light blue wire, and it gave us speed 3 or medium 2, whatever you want to call it. If you were going to pick a speed, you can go with any speed that you want. It didn't matter. As long as the circuitry on this side from the resistor over is okay, any speed will work. I've talked about this temporary repair several times over the last 5 years. People did not understand why a relay was involved. I guess what people think you should do instead is to take your light blue wire in this case and your brown wire at the blower motor connector and just tie those into the switch. The problem with that is most switches aren't designed to accommodate that much current going through them. The switch in this example, it just trips a relay, might have 200 millivolts going through it, something like that. Perfect. And as a result, it lasted, well, 3 years. So this is what I know works, and that's what I did. Now, a side note about all of this right here. Back in 2012, I didn't think I'd ever be doing videos on my pickup, so I didn't really film or show anything on it. Didn't even really post that much on it either. But I did try to diagnose what the root cause of this melted connector was, and I could not find a root cause. At one point I tried a new switch. I did voltage drop and amperage readings. I could never get it to do anything. Came back a week or two later and the thing had melted again. I never got a root cause as to what caused it to melt. And as you're going to see coming up in another video, I decided to do an unconventional fix for this. Now this setup lasted for 3 years running it like this. I never had a melted wire here at the relay on the brown wire or the light blue wire. I never had any issues for 3 years since. Something about doing it this way worked. It's my theory, and again, I'm not no mechanical or electrical engineer, none of that stuff. It's my theory that the switches available for this controller are not built to the original OEM spec and cannot pass the current that flows through it when it's powering, speeds 1, 2, and 3. Just a theory. Coming up, we're going to take the success of this 3-year temporary mod and we're going to use it to do a full modification to the HVAC blower circuits that are going to be built to last. Better than OEM. It's not pretty. It was a cold January night repair just to get the blower working in this thing, but it served me well. The tyco relay, the switch, this is all stuff I had laying around, but I would estimate that the cost of this little bypass would probably run around 15 bucks, maybe 20 if you really had to buy every last piece. I've got stuff like tape and connectors and all that shit already, so I really didn't have to buy anything. What I tapped into was speed number 2 because I didn't want this thing going all full blast all the time, and speed 2 was good enough to get me by since January. And when I mean January, not last month January 2012. Yeah, whether you want to call it a ghetto fix or a hack job, whatever you want to call it, it worked for over 3 years, so yeah. So that's pretty much what I did to get the blower working. Now, of course, I had to go and make sure that the blower itself did work. I took the feed wire and just did a little jumper over to one of the speed wires, and the blower worked. Now what I'm going to do for a real repair to get this switch working and all that stuff, I'm going to wire this thing up a little bit unconventionally. I'm going to wire this thing up a little bit unconventionally. Let's go over to the workbench. From a different speed, from low, 2, 3, they are each going to turn on an individual relay. And then just like normal, it's going to put power, through each resistor circuit, depending on which speed you're at. And it's going to go and work exactly as intended. Since the circuits that I'm doing are blue, tan, and yellow, I just got some sky-high car audio power wire. Just little 12 gauge stuff, brown, yellow, and blue. Just, I don't know, That way I don't have like 16 red wires running across the dash. All this dark green one does is it tells the module that the blower switch is off. So I'm going to de-pin that guy. And he's going to go into this bottom pin right here. I'm only going to be using 4 that came with the blower connector. See if I get this right. This is going to be our feed. And these 3 are going to be our speed selections. So I got all 4 speeds back.